Welcome to The Explainer. Today we're talking about something you see literally everywhere but probably don't think twice about: cement. We're going to crack open the surprising science behind the material that, well, builds our entire world.
So when you think about cement, what comes to mind? Probably just a simple gray powder, right? But is it really that straightforward? A one-size-fits-all kind of deal? Well, the answer is not even close.
Thinking all cement is the same is kind of like thinking all flour is the same. I mean, you wouldn't use cake flour to make a rustic loaf of bread, would you? The recipe is everything. And in the world of construction, the recipe for cement is dialed in for some very specific jobs.
All right, so let's dive into that. To really get a handle on these different recipes, we're going to look at how the American Society for Testing and Materials, you'll see it called ASTM, breaks it all down. They've basically created a whole family of different cement types.
And here's our starting point, the one you've probably seen 100 times. This is ASTM Type I, often just called ordinary Portland cement. It's the absolute workhorse of the industry. Think of it as our baseline for everything else we're about to look at.
And here's where it gets really interesting. This isn't just a list. It's more like a toolkit for engineers. You've got your all-purpose Type I, sure, but then you have these specialized versions. One for getting strong, fast, another for keeping things cool, and even one that fights off chemical attacks. Each one is a specific tool for a specific job.
So let's start with Type 3. This is the sprinter of the cement world. The recipe gets tweaked in a couple of key ways. They load it up with more of this strength-giving compound C3S, and they grind the powder super fine. What does that do? It makes it react with water like crazy, so it gets strong really, really fast. Perfect for when you're on a tight deadline or doing repairs in the cold.
Okay, so if Type 3 is the sprinter, then Type 4 is the marathon runner. Think about pouring a massive structure, like a dam. The chemical reaction of all that concrete curing generates an insane amount of heat, enough to cause serious cracks. So to stop that, engineers dial back the two compounds that produce the most heat, C3S and another one called C3A. The result? A cement that cures nice and slow and cool.
And last but not least, meet the defender, Type V. Now, sometimes concrete has to live in some pretty nasty environments, like soil or water that's full of sulfates. Those sulfates will literally attack and eat away at the concrete over time. So Type V's superpower is its resistance. They slash the C3A content way down, making it tough enough to survive in those aggressive spots.
So we've got all these different recipes, right? A sprinter, a marathon runner. Well, this all leads to one of the most fascinating and kind of paradoxical trade-offs in all of concrete engineering. It's all about speed versus strength.
Just take a look at this. At the very beginning of the race, just 7 days in, that high early strength Type 3 is the clear winner. No contest. It's doing exactly what it's supposed to do: get strong and get strong fast.
But what happens if we let the race keep going? Let's fast forward 5 years. Based on real long-term data, check this out. That slow and steady Type 4, the one that started way behind, it doesn't just catch up. In the long run, it can actually end up being even stronger.
It's a perfect example, isn't it? Slow and steady wins the race is a real thing in the world of cement. The fastest, most explosive reaction doesn't necessarily give you the best, most durable result in the end.
And that's the key takeaway here. Speed has a cost. That super fast hydration that gives you that early boost of strength, it also generates a ton of heat and can actually create a weaker internal structure over the long haul. This might be one of the reasons why some really old structures, built with those slower cements, have held up so incredibly well for so long. But wait, the story doesn't stop with these 5 basic types. Not at all. Modern engineers have gotten even smarter, finding ways to upgrade the recipe by throwing some new ingredients into the mix.
And that brings us to something called blended cements. You can think of these as, well, an upgraded formula. So the main ingredient in cement is this stuff called clinker, which you get by heating up limestone. With blended cements, you take some of that clinker out and replace it with something else, usually industrial byproducts like slag from making steel. And the result can be a much better material. Now, there are 2 main ways to do this. You can use slag, and with that, you can replace a huge amount of the original cement, up to 70%. That's because slag is hydraulic, which is just a fancy way of saying it can react with water all by itself. But with other materials called pozzolans, like fly ash, you can't replace as much. They actually need the chemical reaction from the original cement to kind of wake them up and get them working.
So why go to all this trouble? Well, the payoff is massive. You often get concrete that's way more durable, creates less heat, has a tighter, denser structure inside, and is much better at fighting off chemical attacks. There is one little catch, though. You only get these awesome benefits if the concrete is cured right. That means keeping it moist for long enough to let those reactions happen.
Okay, so this whole evolution, from simple recipes to these really complex blends, has totally changed the game. It's actually led to a revolution in how we even think about and regulate cement.
We're in the middle of this big shift from something called a prescriptive standard to a performance-based one. What does that mean? Well, the old way was prescriptive, like a super strict recipe. It would say your cement must have exactly this much of this and this much of that. The new way is all about performance. It's like judging the final dish. We don't really care how you made it, as long as it tastes great, or in this case, as long as it hits the strength and durability targets we need. And that, right there, opens the door for all sorts of amazing new ideas.
So you've got all these different types, these custom blends, these new standards. You'd think we have this all figured out, right? That cement would be perfectly predictable. But there's one last twist, and it's a big one that complicates the whole picture. Get this, research shows that the exact same brand of cement can perform completely differently from one bag to the next. How is that possible? Well, it all goes back to that core ingredient, the clinker. The limestone used to make it isn't the same everywhere. It can vary from one quarry to another. So you could buy a bag of Brand X cement made with clinker from one place and get great strength, but then buy another bag of the exact same Brand X made with clinker from somewhere else and find it's not nearly as strong. It's kind of wild. And this is why engineers are always testing materials right there on the job site. They can't just trust the brand name. So the next time you're walking down the street, just look around. The sidewalk, that bridge, the building you're about to walk into, none of it is just simple gray stuff. It's the end result of a huge, complex puzzle of chemistry, geology, and a whole lot of engineering choices. Which really makes you think, what hidden story is the concrete all around you trying to tell?